750 light-years from Earth, something is orbiting a dead star. It has the mass of Jupiter, it completes an orbit every 8 hours, and it's shaped like a lemon. That alone would be strange enough. But what scientists found inside its atmosphere has them questioning whether this thing is even a planet at all. There's a reason one researcher looked at the data and said out loud, "What the heck is this?" And there's a reason the answer might force us to create an entirely new category of cosmic objects. But first, let's talk about that dead star. When a massive star runs out of fuel, it doesn't just fade away, it collapses. The outer layers explode outward in a supernova, while the core crushes down into something almost unimaginable, a ball of matter so dense that a teaspoon would weigh 1 billion tons. The result is a neutron star. Some of these spin fast, hundreds of times per second, and as they spin, they shoot beams of radiation from their magnetic poles like cosmic lighthouses. We call these pulsars. The object we're talking about orbits one of these pulsars. It's so close, just 1 million miles away, that it completes a full orbit in less than a single workday on Earth. At that distance, the gravity is extreme. The pulsar's pull is so strong that it's stretching this object, warping it, deforming it into an elongated shape that looks less like a planet and more like a piece of fruit. That's bizarre, but here's where it gets truly strange. The James Webb Space Telescope turned its infrared instruments toward this system, expecting to find a typical planetary atmosphere: water vapor, methane, carbon dioxide, the usual suspects. Instead, it found something that shouldn't exist. The atmosphere is made of helium and carbon, specifically molecular carbon in forms called C2 and C3. There's no oxygen, no nitrogen, no water, just carbon, floating through the atmosphere like soot. And at the temperatures measured between 600 and 2400 degrees, this molecular carbon shouldn't even be stable. It should break apart, but it doesn't. Let that sink in. Everywhere else in the universe, wherever scientists find carbon, they also find oxygen and nitrogen. It's one of the most consistent patterns in cosmic chemistry. Carbon doesn't exist alone, except here. This object breaks the rule. And it gets stranger. Deep inside this alien world, the pressure is crushing. Carbon under that kind of compression doesn't stay as gas or soot. It crystallizes. It becomes diamond. Scientists believe that inside this object, diamonds may be forming continuously and falling, raining down toward the core. A never-ending diamond storm in a lemon-shaped world orbiting a cosmic lighthouse. So what is this thing? The researchers considered every explanation. Maybe it formed like a normal planet, condensing from a disk of gas and dust around the pulsar, but the chemistry doesn't match. Planets don't form with pure carbon atmospheres and no oxygen. The building blocks aren't there. Maybe it's a captured object, something that wandered too close and got trapped. But captured objects don't end up in such tight circular orbits. The physics doesn't work. Then came the hypothesis that changed everything. Remember that pulsars are born from dying stars? Sometimes when a star collapses, it has a companion, another star orbiting nearby. The pulsar can begin to feed on that companion. Its radiation strips away the outer layers. Its gravity pulls material across the gap. Over billions of years, it devours its partner piece by piece. What if this lemon-shaped object isn't a planet at all? What if it's what's left of a star? The math is haunting. If this object started as a small companion star and the pulsar has been feeding on it for billions of years, we might be seeing the final fraction of 1%, the last remnant, a stellar corpse, so stripped down that only its carbon-rich core remains, stretched into an absurd shape by the very gravity that consumed it. Scientists call systems like this black widows, pulsars that eat their partners. But even by black widow standards, this one is strange. The carbon chemistry, the lack of oxygen and nitrogen, the exotic molecular forms, nothing quite fits. The lead researcher put it simply, did this thing form like a normal planet? No, because the composition is entirely different. Did it form by stripping the outside of a star? Probably not, because nuclear physics doesn't make pure carbon this way. I'm open to the possibility that this is an entirely new type of object that we don't have a name for. That's not speculation. That's a scientist staring at data that breaks the categories. Here's why this matters beyond the strangeness. For decades, we've classified objects in space by how they form. Stars burn hydrogen, planets form from disks. Brown dwarfs are failed stars. White dwarfs are dead stars. The categories seem clear, but this discovery suggests the boundaries might be blurrier than we thought. Objects can transform. A star can become something planet-sized. A planet-mass object can have the composition of a stellar remnant. The labels we use may be convenient, but the universe doesn't care about our filing system. The James Webb Space Telescope made this observation possible because of a cosmic accident. Pulsars emit mostly gamma rays, invisible to Webb's infrared detectors. So while the pulsar blazes with radiation we can't see, the planet-like object shines clearly in infrared. For once, the star didn't blind us. We could study the companion directly, measure its atmosphere, map its temperature variations across its orbit. What we found raises more questions than it answers. If this object is the remains of a devoured star, how long does it have left? Will the pulsar eventually consume it entirely, leaving nothing behind? If it's something new, something that doesn't fit our categories, how many more are out there hiding in data we haven't analyzed yet? And perhaps the deepest question, what does it mean for a star to die this way? Not in a blaze of supernova glory, but slowly over billions of years, stripped and stretched and reduced to an unrecognizable lemon-shaped shadow of what it once was? We may never know exactly what PSR J2322-2650b is. The data will be debated, models will be refined, new observations will add detail. But right now, in this moment, we're looking at something that defies easy explanation. A world that rains diamonds shaped like a fruit, orbiting a dead star with an atmosphere that shouldn't be possible. Sometimes the universe reminds us that our categories are just guesses, and sometimes the truth is stranger than anything we imagined.